Hi dear students, welcome to my channel. This is continuation of the gravitation chapter. Today class, what we are going to do, we are going to calculate the speed of International Space Station. Presently, Sunita Williams, astronaut, she is in International Space Station. With what speed she is rotating around the Earth, we will calculate. So before that, we will discuss some fundamentals regarding it. If I drop this object, what happens? It is falling down. But International Space Station, it is not falling towards the Earth. Why? Then why it is falling? So not to fall towards the Earth, what have to do for this? That is the most important thing we should understand. So here you should understand what is force. Force means, rate of change of linear momentum. If you apply a force on an object, it will accelerate. You are applying force on an object means the object will accelerate. Accelerate means the speed or magnitude of the velocity is changing, increasing. It means the force is doing something. The force is doing something such that the magnitude of the velocity is changing. Otherwise, I will maintain the magnitude of the velocity constant. Still I apply a force. What happens? If you apply a force on an object, it has to accelerate. Agreed. Accelerate means, already I told, the magnitude is changing. But now I am telling, the magnitude remains constant. Still I am applying a force. What this force is doing? The force is changing the direction of the object. The force can change the magnitude of the velocity, or force can change the direction of velocity. The space station presently, which is at 400 kilometer height from the surface of the Earth, it is continuously moving around the sun, around the Earth. Of course, Earth is moving around the sun, that will also move. But precisely I am telling, the International Space Station continuously moving in a circular path, nearly circular path around the Earth. The direction of velocity of International Space Station continuously changing due to a force. That force is called gravitational force. Here gravitational force playing a role of centripetal force. Centripetal force is not a new kind of force. It is a role of force. Centripetal force come into the picture if that force is doing change in the direction of velocity. That force is playing a role of centripetal. Here the gravitational force on the International Space Station due to Earth playing a role of centripetal force. See here, this is the Earth. Here some space station. This is some kind of space station. It is continuously rotating in circular path, nearly circular path around the Earth. This is the gravitational attraction force, Fg. The gravitational attraction force on the International Space Station due to the Earth. but it is not falling down towards the earth. So this force making, this is the instantaneous velocity, no, direction. So this velocity direction continuously changing. This force making this object or International Space Station to move in a circular path. This gravitational force playing a role of centripetal force. Now we will equate the gravitational attraction force on the International Space Station. Centripetal force formula, you know, mv square by r. Suppose mass of the International Space Station is m. So it is moving with a speed v. Centripetal force Fc is equal to mv square by r. R is the distance of International Space Station from the center of the earth to here. So what is this force? Gravitational force. What is the gravitational force? Capital G, capital M, that is the mass of the earth, and small m, mass of the International Space Station, divided by r square. So this m cancel you can do. So this m you can cancel. What else left? V square by r is equal to capital G, capital M divided by r square. This will cancel. V is equal to under root capital G, mass of the earth, divided by, this is r. R is the distance from center to International Space Station. So what you are getting, capital G and capital M, universal gravitation constant, and mass of the earth, r is the distance from here to here. Radius of earth is 6,400 km. The distance of International Space Station from the surface is around 400 km. So 6,400 plus 400, 6,800 km. You substitute, you will get its value is approximately this much, 7.66 km per second. International Space Station is moving around the earth 7.66 kilometer in 1 second. Is it small? It is very big. It is huge. Earth is rotating about its own axis. I am also rotating. Each and every particle on the surface of the earth, which is at the equator, is rotating. Then what speed of mine? My speed presently, your speed also, that is 1670 km per hour. 1670 km in 1 hour. Even though you are sleeping or sitting, you are doing anything, your speed, because you are on the surface of the earth, you are near to the equator of the earth, any point on the equator moves continuously with respect to the center of the earth with the speed 1670 km per hour. So in terms of kilometer, 0.46 km per second. My speed is 0.46 km in 1 second or 1670 km per hour. Why I am telling this? I am comparing the speed of International Space Station with respect to our speed on the surface of the earth near to the equator. It is very less. We are just 0.46 km per second. Now Sunita Williams rotating around the sun with the speed, rotating around the earth. Presently Sunita Williams, International Space Station, rotating around the earth with 7.66 kilometer per second. You understood, no? Okay. Thanks for watching this video. Please like this video, share this video and subscribe my channel. Till next video. Bye bye.